Hey everyone, welcome to my channel. I'm Krittika. Today I'll be demonstrating a project with you all of mine that works on a wave-based physics model. The model is simply Simple Harmonic Oscillator, and it is based on some wave technologies which I have inculcated while making this code, such are HTML, CSS and JavaScript. We'll get to see all of them, the codes. I have written a thorough explanation of each and everything that will be helpful for all of us to understand. Let's start with the introduction and aspect. This project presents an interactive wave-based simulation of simple harmonic motion, specifically demonstrated through a mass spring system. Simple harmonic motion is a special type of periodic movement where the restoring force is directly proportional to the displacement and acts in the direction opposite to the displacement. This relationship is governed by Hooke's law. It is all that we are accustomed to. F is equals to minus Fx, and is central to understanding many physical phenomena, from the swinging of a pendulum to molecular vibrations. Now comes the purpose of this project. The primary goal of this simulation is to provide a clear visual and real-time model of this oscillatory behavior. Unlike static diagrams or pure mathematical equations, this interactive model allows users to directly observe the relationship between position, velocity and acceleration over time. It visually demonstrates the conservation and exchange of energy between potential and kinetic forms inherent in SHM. Now we'll be coming to the technical implementations. The simulation is built entirely using standard wave technologies. The first one being HTML for structuring the mass and spring elements. Second is CSS for visual styling and rendering, and JavaScript for the core physics engine. The motion is calculated using a basic numerical integration method, the Euler, in a continuous animation loop. This approach translates the continuous differential equation of SHM into a discrete step-by-step computation that the browser can render, bringing the physics to life. Now I'm sharing the codes of the different wave languages that I have used. First one being the HTML, as I said. It is for structuring the mass and spring elements. The second is the code for CSS. It is for the visual representation. It just basically adds on the visual effects of our oscillator. The third is the JavaScript. It is mainly based on the integration Eulers, as I have mentioned before in the technical implementations part. Alright, now let's move on to the simulated link and see how it works. Alright, this is the Simple Harmonic Oscillator simulation. Actually, I'm very much sorry. Right now the web browser of my PC is not working properly, so I had to make a short video of it, and then I'm sharing with you in this YouTube video. So basically, as you can see, it was just oscillating, and that was our basically purpose of this whole project. Alright, next we'll meet in the conclusion part. Now let us come to the main conclusion of the project. The mass spring system was accurately modeled using HTML, CSS and JavaScript, as already mentioned earlier. This simulation stands as a clear example of how numerical integration can bring core concepts of classical mechanics to life within a web browser. Thank you everyone for watching the video and staying with me. See you in the next one. Bye.